Okay, kids, let's learn about electrostatics. Think about that word, electro, from electron, electricity, moving, but static means not moving. Thank you very much. Next show, 4 o'clock, tell all your friends. All right, so electrostatics is kind of a misnomer in terms of, it's not like an oxymoron. You have electricity, you gotta have things moving around, not electrical force. Electrical force, you don't have to have things moving. It's Coulomb's law, and it's effective between things not moving. But I have electricity, you gotta have things moving. So kind of a weird name, electrostatics, but there is a type of physics that's called electric current, and that's flowage. Flowage, that's a good word, flowage. Yep, it's true, I looked it up. It's a word. And in order to have any of this electricity, we're going to have charge. Charge. We have to have charge. And we all know that there are two kinds of charge. Yes, we do. We know there's positive and negative. Now, you don't have to be charged. You don't have to be positive or negative. You can be like Switzerland, which is neutral. Okay? Switzerland is strictly cash, no charge. No charge. Strictly cash. No. Look at that as 0, meaning uncharged. But if you're neutral, then we're not going to have any of this stuff happening. Neutral things don't do electricity. Okay? You've got to have either positive or negative to do electricity. Now let's talk about that. A little bit of the electrostatic demonstrations, show you some electrostatics. I've got some stuff here. Okay, let me tip you over for a second. Okay, I know. Oh, easy. Whoa. We have here something called an electroscope. I'll show you that. And then we have a piece of, plastic. And then I have a little styrofoam ball here. I've got a piece of glass. There's a glass rod. A little piece of paper. I've got some fur. Okay, some fur here. This actually here, you can see this fur. This was my cat Fluffy. Fluffy was a bad boy. But Fluffy doesn't bother me anymore. Poor Fluffy. Oh, sorry, snap it up. Oh, sorry, flashback. Okay, now, so what we're going to do is take some of this paper. I showed you one little piece of that paper, but over here, I tore this paper from, this is an ordinary high-quality Made in America paper. All right, we'll just take a little piece of it here, and little piece. See? Little piece. There, where are you? There you are. Oh, look, there we go. Little piece. And we're going to set it down on the table. Okay, set it down on the table. Move you back a little bit. We're going to tip you downward. Okay, so you can see the magic that's going to happen. So here's a little piece of paper right here that I just tore off. Now, if I touch it like this, that actually neutralizes it, or it grounds it. Actually, the technical term is grounds it. You're not going out for a week, young man. Grounded. No, not that kind of grounding. You're all familiar with that, I'm sure. I'm talking about it doesn't have any charge. Grounding something means you make it electrically neutral. And you can do that by touching something, because a person is a very good what's called electrical sink. We're a good sink for electrons. Extra charges, that means that we can absorb those and take those away and neutralize something. Okay, so let me rub. We got Bunny here, Fluffy was my kitty, not my bunny. And I'm gonna take the plastic and I'm gonna rub plastic. Now, it's really not a good electrostatics day out. We are entering December, and December is a good month. January, nice dry months. You know this. You know there's electrostatics during the dry months of the winter. You know this. Like sometimes you rub your butt, rub your butt on a car seat when you get out and you touch the door, you get a little snap. But that doesn't happen in the summertime. It only happens in the wintertime when it's dry, and we can get some electrostatic action going on. And we'll go over how come that is. But for now, so it's not really, it's a warm day. So actually a very warm day out. It's in the 60s today. It's kind of weird. And it's not a good electrostatics day, but let's see if we can get something going on here. We're going to rub this plastic. And come on. Oh, we had it. We had it. Come on, come on. We had it. Didn't quite want to go. Let's, we got it to lift up a little bit, but let's see if we can get this, make some magic happen. Mr. Gundram's magic. Yes, he is. No, I'm not. It's just physics. Just physics, people. Come on. Oh, that's what I'm talking about. Yeah, that bad Larry jumped right on there. Yep, there we go. Jumped right on there. Said, let me get up there. I'm attracted to you. Yes, I am. And so now we have taken that piece of paper and we attracted it right to that piece of plastic. Even though it's not a very good electrostatic day, we got some electrostatic effect. Now I can, leave this here. It falls off eventually. If I shake it, of course, it falls off. Let's try that. Let's try that with same piece of paper. Same piece of paper. No tricks going on here. Mr. Graham's not doing tricks. He's not doing magic. I mean, it looks like I'm doing magic, but I'm just doing physics. And I'm going to take the glass rod and try the same thing. Now, glass can also be charged. It doesn't tend to get as much of an effect as plastic does. It's harder to charge the glass. We'll rub it here and see if we can get it. If I can lift this up, that would be really magic. But we'll see if I can, pick it up. But if I can get it to move a little bit, jump. Oh, good boy, stay. Can you see that? Yeah, we got it to jump up. I can't quite, oh, Mr. Gundram is a magic man. Look at that. Yeah, so we did get that to jump up. All right, well, that's good. Sometimes it doesn't work with the glass. Okay, we give a little boop. A little shake, it'll fall off there. Okay, so now we can see that the plastic and the glass both can lift up a piece of paper, and we need to go through why that happens. It's actually important why that happens, to understand electrostatics, what's going on to make that happen. We have a plastic ball here. This is, sometimes you get the plastic ball to react as well. Let's see if we can get this plastic ball to react here. Not much. The ball's too heavy. Okay, get out of here, you stupid ball. You ruin things. Let me show you this electroscope. Electroscope? That sounds like it's going to be magic, like lightning bolts coming out of it and stuff. This is going to be so cool. Well, actually, it's really going to be kind of boring for you, but it's important to understand what goes on with this electroscope. Okay, actually, let me straighten you back up. Straighten you back up here. Okay. There we go. You're back. I'm back. Woo! Back. All right, now, this is an electroscope, and I will draw it. You can see if I hold this up close to the camera, you can see inside there we have a metal rod that goes through a rubber, what do you call these things? Stopper. Goes through there, and I've taped two thin pieces of aluminum foil at the bottom of them. There they are. Two thin pieces of aluminum foil are taped onto that metal rod. And let me show you what it does. Well, actually, let me draw it up first. And so what we got going on here is you got a bottle, neck of the bottle, like this. We've got a rubber stopper. We got this piece of metal. It goes through the stopper, and down at the bottom of it, I have two pieces of aluminum foil that are taped on there. Okay, now, so what I can do, what an electroscope does is it shows if something is charged. It's not really exciting. It just shows if something is charged or not. It can't tell you what kind of charge it is, but they can't speak anyways. Well, I can't tell you. I can tell you positive or negative. No, you can't. No, stop lying to the kids at home. Don't do that. It's not nice to deceive them. Okay, but what it can do is it can show you if it is charged. So something have a charge or does it not have a charge? An electroscope can tell you that. Oh, how does it do that? Okay, so let's say we take the Fluffy. Little Fluffy, you were such a good little kitty. No, he wasn't. It was a mean kitty. That's why I took care of him. And then we rub. Okay, we're charging up the plastic. And if I move it close to the top, if I move it close to the top here of the electroscope, let me turn this so you can see, you should be able to see those little feet there move far, I call them feet, little pieces of aluminum foil, move farther apart, and when I pull away, move closer together. I'm not getting much of an effect here. I'll do it again. I'll do it with the glass as well to show you that it can see that the charge, that the glass is charged and so is the plastic rod. Let's see if we can get that up there for you and get not much there. That was even less. I mean, it's not moving very much today. I can't even see if I can see you looking at that. Okay, I'm going to do it one more time with the plastic. This usually gets good and fired up. And let's see if we can get the show. Let's see the camera there, the 2 feet there. Yeah, you can see them moving a little bit. It's not dramatic. It's not a good day for this, but you can see them moving. I'm actually taking the rod. I'm moving it close. I'm not touching. I'm not touching the metal. I'm just getting close to it. So I'm doing that. I'm just kind of moving it back and forth, back and forth, back and forth. You can see the little feet there. They do this. They go. When I move it close, they go. And then when I move it away, they go back to where they were. So why is that? What's going on with that? We need to know what's going on with that as well. So the electroscope shows charge. It doesn't tell me what kind, but it shows it's charged. All right, let's get into this. Why the things are doing what they're doing. It's important to understand this, to understand electrostatics. So what I'll do is we've given you some demonstrations in this video. A couple, I mean, not really exciting. It's not like you're going, oh boy, I want to be an electrostatic physician. A physician is a physics person. Did you know that? That's where the word comes from. Physician comes from physics. Yes, it does. Yes, it does. So I'm a doctor. Yeah, that's right. Dr. Physics, call me that, yeah. Where was I? So did some demonstrations, not like earth-shattering, but just enough to show you a little bit of electrostatics on this non-electrostatic-y day out. But we did the job, we did what we needed to do. Now we're going to explain why those things did what they did, and that's the important thing. Be back.